Yeah, we are looking at the practice questions that covers the 5 essential rules for integrations. Okay, and we have the following set of questions to look into. The question one is straight away, very simple. This will be 2x plus 3 all over 10 plus 1, that's 11 over 2, then plus c. But if you check one of the rules that says that when you multiply the variables by a constant, you need to divide by that constant, which will be what? 1 over 2. Okay. This one is what? 11 is there, so this will be what? Over 11. This will be over 11. So that's your answer to that, which now become, this will become 1, this will be 1 over 22, 2 times 11, 22 into bracket what? 2x plus 3 plus c. So that's that. Let me recap it once again. Follow the general integration rules. This is 10 plus 1, which is what? Over 11. Okay, then again, check the variable. Any attachment to that, if there's any attachment, use that attachment to divide your answer. So that's what we have done that. Question 2. Question 2, we are going to rewrite that question 2 into this format. Question 2 will be equal to 2x plus 1. This is half. That will be minus half. This is half. The 1 over will make it minus. Okay, integral of that, dx. And that will be equal to 2x plus 1. This one plus 1. That will give you half. Okay, then divide by half, which will be what? Which will be 2. Okay, and don't forget there's attachment to the variable. That's a 2 to the variable. Okay, use that 2 to divide. Okay, so this one will cancel. Let's see. So that's your answer. So you have 2x. You have your answer is root 2x plus 1 plus c. So that's that on question 2. And that will take us to question 3. Question 3 is the integral of sine 3x plus 3 dx. This is very straight way. Integral of what? Sine is what? Minus cos of the function. Okay, then plus 3. Then check the variable. Any attachment to that? That is 3 there. Okay, what? 3. Let's finish that question. Question 4. We have integral of cos square x dx. I've told us that cases like this, we can't go further. All we have to do is to use the identity. And the identity I'm going to use is cos 2x equals to what? 2 cos square x minus 1. Okay, don't forget that this one is also equal to 1 minus 2 sine square, 2 sine square x. But this one will not be applicable for this question. It won't be applicable. So this will be applicable because what we have is what? Cos square x. Then we try to make this one the subject. Then move this minus 1 to the other side. So we have cos 2x plus 1. Then divide by half equals to what? Cos square x. So we're going to replace our question here with this expression. So we now have cos square x dx is equal to half. Let's take the half outside the integration into bracket cos 2x plus 1 dx. And this will be equal to what? Half into bracket. Integral of cos is what? Is sine 2x. But don't forget that it's attachment to the variable. That is used to divide. 1 over 2, then plus what? Plus integral of 1. So that's what? That's x. And then plus the constants. Okay? If you like, you can open the brackets. If you like, that will be equal to what? 1 over 4 sine 2x plus x over 2 plus c. So that's the end of question 4. We go to question 5. We have integral of this s squared s squared plus 3 dx. So what we can do in this case is, let's call the denominator u. So we call the denominator u. So we can have the u be equal to what? The derivative of this one will give us of the power here is 2x. 2x s squared plus 3. So that's what we've gotten. So, and then that will be what? Dx. So, is that clear now? So that's what, no, sorry, please, sorry for the little, this will be, if you differentiate this expression, you have 2, the derivative of the power here is what? Because you have two functions here, you have the exponential and you have the constant. So the derivative of this exponential will be, check the power, that's 2x times the exponential. And then the derivative of 3 is what? Is 0. So you have what? The x. So that's what we've got it. So then look at your question. You can see that this one is equal to the old expression, which you can write as x e s squared dx all over what? E s squared plus 3. Okay? So this will now become integral of this one is du, the numerator is du, and the denominator is what? Is u. Check very well. Your du is 2x e to power s squared, which you have dx. That's your du. And then du. So we can now see that we're having what? ln what? ln u. Ln u. This is written as integral of 1 over u du. ln u. And derivative of 1 over u, integral of 1 over x or 1 over u is what? Ln of the denominator. Because if you check, the derivative of u is 1, okay, which is equal to what? The numerator. So plus c. So the next thing to do is to return back the what is u. Replace your u, substitute for u, that's ln into bracket. Your u is what? E x squared plus 3 and then plus c. So that's your answer to that. And that will take us to question all over u log u squared e. Okay, so this will be equal to 1 over u all over log u squared is e. Okay, if you like, you can put the u on the top. Okay, it's the same thing. We have not done anything. This and this are equal to each other. So you can bring this u up. It's the same thing. Then the next thing to do, if you solve 1 over u divided by this, you get this one back. You get it back. And this is it, 1 over u divided by log u squared with e. And that will be 1 over u times 1 over log u. So if you have cases like this, it's far better to do it this way. Make your work easy. Then the next thing to do now, can you check this one very well? Take this one out. The derivative of that, the derivative of this will give you, this is the derivative of u squared, that's 2u over the function itself. And that will be equal to 2 over what? 2 over what? 2 over u. Okay? So you can see that the only difference, you can see that this numerator almost equal to the derivative of this. Almost. So what we have to do is just for us to do a little manipulation, and that will be equal to what? We'll force it to be 2 over u. Okay? Which is the derivative of the denominator. Okay? But don't forget it is one that was there or that is there. So we take these two that we introduce, cancel it outside. Okay, over what? Over log u squared is e. Is that clear now? So our answer will now become half e, that is outside here, and then log is e of log of what? Of log of the base. So that will be the answer. I'll try to recap it again. You check it very well. What we did is we did the algebra, we were able to write in this form. Then after that, we check the derivative of this, which I call dd what? dd of this function, which is equal to what? 2u, the derivative of this is 2u over the function itself, which is 2 over u. Okay, that's the derivative of the denominator. Check the numerator and denominator and see the relationship between the two. Then realize that this numerator is almost equal to the derivative of the denominator. Okay, so it is 1 over u and the derivative is what? 2 over u. So let's force it to be 2 over u. Okay, so we introduce 2 to that numerator, and then we cancel it out. Whatever you introduce must be cancelled outside, and that's what we have done there. Okay, so in that case now, we now realize that the derivative of this is equal to what? Is equal to, the derivative of the denominator is equal to numerator. Okay, or the numerator is equal to the derivative of the denominator. And when that happens, it will be what? It will be log to base e of that function. Okay, log to base e of the denominator. When the numerator is equal to the derivative of the denominator, your answer will be what? Log to base e of that denominator. And that's what we have done there. Then plus c. Then we go to next question, which we have this cos this all over cos x plus sin x. Okay, can we do something? Can we call the denominator u? That's cos x. This is minus, please. This is minus. Let's call the denominator u. So the u is equal to what? Minus sin x. Minus sin x. And then minus cos x. Okay? Then dx. Okay? Can we factorize it? Factorize the negative outside. So that will be equal to what? Take minus out. Then we have cos x plus what? Plus sin x dx. So that's what we have done. Then check very well. Yeah. Look at your numerator. Okay. Can you shift this minus to this side by multiplying 2 by minus? So you have minus du equal to what? Cos x plus what? Plus sin x. Okay. Then dx. So this one now will now become integral of the numerator is cos x plus sin x dx. Okay, all over cos x minus sin x. So in that case now, this will now become, you can make your substitutions. This is your numerator, is the same thing as what? Minus the u. Check it. Minus the u all over. Your u is what? Is the denominator, that's u. So can you take this minus out? So that will be minus integral all over u, the u. And that's equal to what? Minus what? Minus ln u plus c. Then return your u back, which will be equal to what? Minus ln. My u is what? Is cos x minus sin x plus c. So that's my answer. That's my answer. And if you want to go further, you can take this minus on top here, which will become ln cos x minus sin x minus 1. You have the time of c. Okay? So that will be equal to 1 over that. Okay, then we go to questions. Now please, if you have questions, you can forward your questions in form of comments, and then we promise we'll respond to your questions as fast as possible. And if you are new on this channel, please hit that notification bell so that as we upload, you get notified. Question 7. Integral of dx over x squared minus 2x plus 5. So what we're going to do, we're going to take this x squared and express as a perfect square. Okay, sum of square. Okay, by using completely the square method. So take one of these. What do you have here? Sine, minus here. Okay, then add half of these two. Okay, which is what? 1. And then square. Okay, so whatever you are adding, can you take it outside, subtract it? Minus what? 1 square plus what? Plus 5, which is equal to x minus 1 square plus 4. So we have expressed it as what? As sum of what? Sum of squares. Okay, so this will now become, integral of what? Dx all over x minus 1 square plus 4. And don't forget our standard table, our rules that say that either a squared plus s squared. That's the arctan what? Arctan x over a, then 1 over a, then plus c. So we're going to apply that, and that will be equal to arctan x minus 1 over 2. Yep, over 2. Then we divide by what? By 2. Then plus c. Because your a in this question is 2. 4 is 2 squared. Okay, then next question, 72. Integral of dt over 16t squared plus 1. Okay, so we can call this one, because we expect this one to be multiple. We expect this one to be multiple, so we can say let u be equal to what? 4t. So this will be multiple of this, multiple of this. So take one of this, to 4t. So the u is equal to what? 4 dt. Can you make dt the subject? So the u over 4 equal to what? Dt. So I can go back to my question, and this will become, the t is what? The u over 4 equal to what? Equal to, this is a u squared plus 1. And then the 4 here can come outside, which is 1 over 4, integral of what? The u over u squared plus 1. And don't forget this arctan. So this will be equal to arctan u. This will be equal to arctan u 1 over 4 here. And then plus what? Plus c. So plug in back your u, which will be equal to 1 over 4 arctan. My u is what? My u is 40, and then plus c. So that's that on that question. The x is equal to s squared plus x plus 5 over 4. Okay. This one also we can express it. We can express this. Let's take the denominator and express it as sum of square. So which is equal to, take one here, one of this. Okay, then half of 1, so this is s here. Half of 1 is half plus half square. Okay, can you also take out what you added? Minus half square. Okay, then what do you have here? 5 over 4 plus 5 over 4. So this is equal to this one times this one, that's 2x plus 1 over 2 all square. Then followed by, let's take up, that will give us a plus 1. Plus 1. So that's plus 1. So this will be equal to, we can come back here, so that'll be integral of dx over 2x plus 1 over 2 all square plus 1. Okay, and this will now become arctan 2x plus 1 over 2 and divided by 1. So it has no difference. So that's that. And then plus what? Plus c. Okay, so that's that on that question. That will take us to the next question. Question 8. Integral of the theta over 1 minus what? 16 theta squared. Yeah, so square root. We can do it straight away, but let's make it easy. Let's u be equal to 4 theta, because this 16 theta squared is same thing as 4 theta squared. So let's take one of that. So the u is what? Is 4 the theta. Okay. So can we, so that'll be the u over 4 equal to what? The theta. So we can substitute there. So we have integral of the u over 4 all over 1 minus what? 1 minus u squared. That will be equal to, this one can come outside, 1 over 4 integral of what? 1 over 1 minus what? 1 minus u squared. And that will be equal to 1 over 4 arc sine arcsine u. Okay, arcsine u. And then you can replace your u is what? 4 theta plus c. Okay, so if you want to do it straight away, you must expect to have a double here, so that we got to arcsine 4 theta. Okay, then you divide by what? By one of this. This is 4. So 1 over 4. So that's that on that question. The H part 2, integral of the theta all over 15 minus 4x minus 4s square root. Okay, let's take this one out. 15 minus 4x minus 4s squared. Okay, if we take it out, then you have take 4 out here, minus 4 out. Okay, so that will be equal to s squared, and this will be equal to plus what? This will be equal to plus 1 plus 1. Okay, then minus 15 over 4. 15 over 4. So this will be plus x here. Plus x plus minus 15 over 4. Plus x minus 15 over 4. Yeah, minus 4x. Minus 4x. Okay. So then the next thing to do, now we got to minus 4. We want to express as a perfect square. Take one of these. Then we're adding half of 1. That's the half here, or square. Then take that half out. Minus half square. And minus 15 over 4. Open your brackets and close your brackets. Okay. So then we have minus 4 into brackets 2x plus 1 over 2 all square. For this one times this one, 2 times x, that's 2x plus 1 over 2. If you solve this one, this will be minus 4. Yeah, that's minus 4. That's minus 4. So if you open the brackets, 2 square is here. So this will be equal to minus 4 into bracket 2x plus 1 all square. And this one times this one, that's what? Plus 16. So this is equal to 16 minus here, this 4 here has already gone, so there's no more 4 here, only minus we have there, because this fraction is the denominator here is 4, so the 4 and 4 here has already cancelled out, so we just have minus there. So that will become 16 minus 2x plus 1 squared. So that's what we have there. Then we can go back to our integration, and that will be equal to integral of what? Integral of the theta all over square root 16 minus 2x plus 1 all squared. Okay, so that's what we got now, and that will be equal to arcsine 2x plus 1 over this one over 4 plus c. So that's that on that. Okay, there's attachment to the variable here. There's a 2 that attached to the variable, so that's 1 over 2 divided by that attachment. That's 1 over 2. Okay, so that's that. I think we can quickly recap that. We can recap that and see what happened. The first thing we do, that happened here is that we want to express this as sum of square. Okay, and that's what we want to do. And then we have to use a difference of 2 square. So take that expression out, and what? We're going to take your minus 4 out, so that we can have the coefficient of s squared as 1. And that's what we have done in that case. And after that, we want to express, complete the square method, one of these, okay, then half of the coefficient of x, which is what? Half, 1 over 2, add it to that expression, and then square it, and then minus whatever you are adding here, you take it out. Half of the square of that, the square of what you are adding here, you take it out. And then already you have what? 2 over 4 there. So when you solve this 2, you have 4. Then allow this minus 4 to come in. Then you have minus of this expression here. Then minus times minus, that plus 16. Then rearrange it. That was 16 minus 2x plus 1 or square. And that's that. And that will be from the table of the integral, where you have integral of the x over square root a square minus s square. So this will be equal to arc sine what? Arc sine x over a plus c. Okay, so that's what we did in this case. But there's this exception to this rule. There's an attachment to this x, to this variable. So we need to use that attachment to divide the answer. And that's what we have done there. Then we'll go to question 9. We have u du over 1 plus what? 1 plus 4u squared. Okay? Plus 4u squared. Without wasting time, the derivative of this denominator is 8u. Okay? So I'm going to make this one to be 8u, du. Okay, but I'm going to cancel that 8 outside. 1 over 8, 1 over 1 plus what? 4u squared. Okay, I don't think we need to talk more on this because we have spent time to explain this. I think these are the rule number 5. Yeah. So, and this will be equal to 1 over 8 log to base e of the denominator. Yeah. So that's that because the numerator is equal to the derivative of the denominator. Okay. We have forced that. Okay. Then the next question we have done that. We have done that. The derivative of this one is 8u. Okay. Then this is u here. So how can you make this one to become 8u? Multiply it by 8 and take it outside. Divide it also by 8. That's what we have done there. Okay. Question 9.3. Integral of 9.3. Integral of u over 1 minus 4u squared. Yeah, the square root. Okay, the square root. This one we can do straight away. This will be the u over square root of 1 minus 2u squared. Okay, and that will be equal to arc sine 2u over 1. Okay, then don't forget to divide by what? Attachment to that u. That's 1 over 2 plus c. That's all. That's all. That's all. Okay, that's all. Which will be integral over 2 tan x sec square x over 1 plus tan square x. Okay, what can we do now? I think it's easy. Let's call this one u equal to 1 plus tan. This is the x tan square 1 plus tan square x. Okay, so the u will become the derivative of this one is what? Is 0. The derivative of this one will be 2 tan the power 2 minus 1. Okay, the function. Then the derivative of tan itself, which is what? Sec square x. So you can see it's straight away the same. So we don't need to waste the time. It's straight away the same. The numerator is equal to the derivative of the denominator. So in that case now, our answer will become what? Our answer will be equal to log to base e of the denominator 1 plus tan square x. Okay, plus c. Just finish. I'll finish the solution without wasting the time. Okay, if I want to make adjustment or make substitutions, this will become what? Equal to my u. This one is what? Is the u all over what? U all over u, which is what? Which is equal to ln u. Then plug in your u. Ln u and log to base c, they're the same thing. So that will be equal to ln the function.